File systems are built on top of a selection of LUNs. LUN, which stands for logical unit number, is a logical storage device. In the simplest case, a LUN corresponds to the entirety of a single physical storage device, such as a hard disk drive. But commonly LUNs are created out of a larger pool of storage, either by dividing large physical devices into smaller logical pieces, or by combining individual storage devices, as in a RAID set, and then slicing across them. StorNext file systems are no different in this regard. However, StorNext introduces two layers of abstraction between the LUNs and the file system that provide important expanded capabilities. These layers are stripe groups and pools. This video deals with stripe groups. Pools are optional and detailed elsewhere. The power of stripe groups is their ability to separate data with different characteristics onto storage specifically tuned for that data and the way it's accessed, all within a single file system. For example, if you mix small random I/O with large sequential I/O on the same storage, performance for both will suffer. It's not possible to optimize the same storage for both workloads. Using stripe groups, you can optimize some storage for each workload, maximizing performance without having to manage data across multiple file systems. A StorNext stripe group is simply defined as a selected group of identical LUNs. Data is striped across those LUNs, hence the name stripe group. Stripe groups are very tunable to enable maximum performance. Configurable parameters include segment size, which is the amount of data that will be written to one drive in a RAID LUN before writing data to the next drive in that LUN. Data stripe breadth is the amount of data written to each LUN in a stripe group before writing to the next LUN. And inode stripe width, when set, causes large files to be striped across multiple stripe groups in chunks of the specified size. These and other parameters are set for you when using automatic stripe group configuration, but may be configured manually if desired. Every StorNext file system has stripe groups that hold three types of information. Metadata stripe groups hold file system metadata. Metadata is very small and is accessed randomly. Journal stripe groups contain the file system journal, the sequential record of changes to the file system metadata. Journal data is a series of small sequential writes and only occasional reads. User data stripe groups are the largest and hold the content of user files. There are frequently multiple user data stripe groups in a StorNext file system. In smaller systems with comparatively lower performance requirements, all three types of information may reside on a single stripe group. More typical configurations combine metadata and journal on a single stripe group, but separate user data stripe groups. In very large and very busy systems, additional performance can be attained by separating metadata, journal, and user data onto individually tuned stripe groups. Stripe groups also provide a method for scaling a file system in both performance and capacity, because the LUNs in the stripe group do not have to all reside on the same storage system. For increased capacity, a stripe group may span several large capacity storage arrays, each with many expansion shelves. For scaling performance, a stripe group may span a larger number of lower capacity storage arrays to take advantage of the aggregate array controller bandwidth. Stripe groups are also very useful when it's time to refresh or upgrade storage hardware beneath a StorNext file system. To expand a file system, new storage is added as one or more additional stripe groups. File system clients will begin to use the new stripe groups immediately. Allocation of new files among all stripe groups is governed by the configured allocation strategy, round robin, fill, or balance. The stripe group offload function is used to migrate files off an old stripe group so the corresponding storage can be decommissioned. Offload first sets the allocation status flag for the old stripe group to false. This prevents any additional files from being stored there. Files are then migrated off the old stripe group onto all remaining stripe groups or to a specific stripe group as required. Open files are managed automatically. Once the migration is complete, the old stripe groups and the old storage associated with them may be decommissioned.